Well, hello, pre-calculus. What we're going to do today is start our first lesson in Chapter 1, Lesson 1.1 on functions, domain, and range. And many of these things and topics we'll talk about here are review from your last 2 years from advanced algebra, FST. To help maybe brush off some of the cobwebs. So first thing I want to do is just kind of talk a little bit about functions and give you a little definition for that. And with a function here, we can say a function is a set of ordered pairs. Okay, sometimes we call those just coordinates, where each unique input matches exactly with one output. In other words, you've got a one-to-one relationship. So that's kind of how I like to remember that. So kind of a little picture here of going on. This is a function because we do have here's one input, one x value as an input, and it's going to give me one value for the output. Now, sometimes this gets a little confusing down here because you have two different inputs going to the same output. That's fine because this one input only has one output. This one input only has one output. It just happens to be the same, and that's perfectly fine. Where in this case, here we've got one input that's going to two different outputs. So that's not a function. Okay. So one way, if you remember how to test to see if a relation is a function, when you're looking at a graph, is to use the vertical line test. And basically what you're doing is you just draw a vertical line through a graph. This happened to go through twice, so this one is not a function. So if you can draw a line vertically anywhere and it goes through more than once, then you've found that it's not a function. So if you kind of look at this, this is kind of, look at this, got the same x value for each of these points, but would deliver a different y value. In this graph over here, we see no matter where I draw a vertical line, boom, only goes through there once. Here, boom, only through once. Here, only through once. So no matter where I draw a vertical line, it's only going through once. So this one does pass the vertical line test. So this one would be a function. All right, so there's kind of some basics just about functions. Let's talk a little bit about domain. So we'll move on to the bottom part of this worksheet and talk a little bit about domain here. So domain, I always like to think of domain. When you think about domain and range, your domain are your input values. Also consider your x values. Kind of remember this domain and range. Domain comes before range in the alphabet. X comes before Y. Input comes before output. So kind of a good way to remember that. So when I'm looking at domain, I'm looking at how a graph spans across the x-axis from the infinite left, from negative infinity, to positive infinity. So when I'm looking at this graph right here, I always like to see how far left does it go as a starting point. And if I look here, I see a little arrow on the end, which means it is going, yes, it's going up, but it's also going to the left in a forever motion. So I know here, the furthest left it goes is negative infinity. And as you learned in the past, we've got two different types of closures we'll have on these sets. And With infinities, we always have parentheses because that means we just can't touch it. We can never reach negative infinity. So, we'll put the parentheses there. So then I like to go as I read here from the left, I kind of follow this along as I go from left to right. Yeah, it goes down here, kind of keeps coming back up, still moving to the left, to the right. When we get up here, here we've got an open dot, which means it doesn't touch that. So as I'm reading across, reading along this x-axis, I get to about here, and I can't be equal to 2. It's got an open circle there. So it kind of stops right there. And I can't be equal to that, so I put a parentheses. I'm kind of picking up my pen now and getting over here and restarting myself over here at 3. That is a closed dot. So I know I will start again up at 3, and because it is closed, I can touch that. I will put a bracket. And then as I keep moving to the right, I see this is going to keep going out forever to infinity. And again, infinity always has parentheses. So to represent this whole domain, I started at negative infinity, went up to 2, didn't touch it, had to pick up my pencil, and then start again at 3 and go out to infinity. I want to unite. I want to get the union of those two sets. All right. So kind of just a key point when you see open circles, again, you'll be using parentheses. One of those depending on which way you're approaching it from. If it's a closed circle, that's when you'll use brackets. And moving on, we're going to look at how to find the domain of different functions. And we'll first start off by just looking at how to identify the domain by looking at a graph of this. So what we'll do is we'll just go to Desmos. We'll type this equation in. Many of you might know what this looks like, and we'll review these 12 basic functions to help you remember what these look like, and you can remember how they're moved and stuff, and that's kind of what Chapter 1's about. But for right now, we'll just go to Desmos and type that equation in. So I've got Desmos here at a tab. So we'll end up typing that in right here, and the graph should just appear. So we'll just type in y equals, we can get the square root button. So what you can do here is just type in SQRT, gives you the square root symbol, and then just go x plus 2. So we can look at this graph. You can see if we're reading left to right, there's nothing over here. It's not until I get to negative 2 that that's the first time I've got part of the graph. And if I think about it, I can put negative 2 in for that x value. And the square root of 0 will be 0. So that's fine. Where anything less than that, like I can't put negative 4 in there. Negative 4 plus 2 would be negative 2. And then the square root of negative 2 is not a real answer. And if I look at the graph, I can keep putting answers in for x all the way from negative 2 all the way out here to infinity. So, when I look at this, again, this graph right here, I'm just going to kind of draw this over to the side just to save myself some room there. This graph here started at negative 2, and it kind of went like that. So when I look at writing the domain for this one, what I would do is say, well, it starts at negative 2, and again, I could be negative 2, so I can touch that, and then it's going to keep going to the right to infinity. Do the same thing here with this equation right here, or this expression, and write it as an equation in our Desmos. So I can just kind of backtrack this here, and that was 3 divided by, and then on the bottom, I'm just going to type in the x minus 5, and we can see what that graph looks like. So you might remember this as a hyperbola with the 2 branches right here. It looks like it's got an asymptote right here at 5, and then also another horizontal asymptote here at y equals 0. So looking at making just a quick sketch of that graph, down here, it's got a little branch right here, and then it's got a little branch right here, and then there was this asymptote right here at x equals 5. There's also the horizontal one here, but we're not concerned about that with the domain because I'm going to be reading from left to right. And as I read left to right, it's like way out here to negative infinity. It keeps coming along, and then it gets up to 5, but it can't touch that. So when I write that domain, I'm going to go negative infinity. It's going to go all the way up to 5. Can't touch that. So parentheses, kind of jump over that asymptote wall and unite that and start again at 5 and move out to infinity. But again, 5 can't be touched because it's got that asymptote there. So that's kind of how to use the graph. Just kind of graph that, look at that, read left to right, and see where there are areas where the graph can't exist. But you also want to be able to have the skill to be able to address this with some reasoning as well, too. And what I'm going to do is just kind of give you a couple little tips in looking at some general construction of different equations. If something is some number over x, okay, what we know here is that, again, we can never have 0 in the denominator of a fraction. So I can say that x can never be 0. Otherwise, it could be anything you want it to be. Another little tip I want to give you is that if you look at square roots, okay, square roots in the real world can only be 0 or positive. Because, again, I can put a 0 in there, square root of 0 is 0. But I can't put a negative number in there. So just something to keep in mind as we kind of reason these out instead of having to type these into an equation or to a calculator. And for that matter, you might not have one available, so you have to kind of do some reasoning. So what I'm going to do with this problem is I'm looking at this top part because I see a square root in there. So I'm going to be a little concerned because I know here the number underneath the radical, that 7 minus x, has to be greater than or equal to 0. So just do a little solving here, a little algebra. This would be 7 is greater than or equal to x, or most people like to write the other way and say x would be less than or equal to 7. So I know one of the constraints I have here is that if I make this say 7 right here, okay, I can only have numbers that are here or less. So it's going to be here or less than. But then I got to worry about, because I got a fraction, I've got to worry about those bottom pieces. I can't have that bottom piece be 0. So I'm going to look at each of these pieces here, the x plus 3 and the x squared plus 1. They're multiplied together. And we can kind of go back and look at the zero product theorem, which you learned before. If you take two numbers and multiply them together and they equal 0, well, then either A has to equal 0 or B has to equal 0. So in this case here, I could get a 0 in the denominator if x plus 3 was equal to 0. Okay, and again, I don't want that to be 0, so I'm going to say not equal to 0. So x, oops, what just happened there? That was weird. X can't be negative 3. So I'm going to go back into here, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3. There's negative 3. I can't have that there. So I'm going to go in here, kind of put a little open circle there. And then right here, I can't be negative 3. But again, I could still be up to that, and I could still be down to here. All right. Now, additionally, I'm going to look at this other part, this x squared plus 1, and know that that can't be 0 either. So if I just solve this, x squared can't be negative 1. Well, that's true always. When you square a number, it's never going to be negative. So that's really doesn't affect anything that we have here. So this could never be 0. So when I look at this overall, and if I start at the very far left, I can go all the way down to negative infinity. And as I travel along this number line, I get up to negative 3, and I can't have that. So I'm going to put, again, it doesn't touch it, so I'm going to put a little parentheses there to show that I can't touch that. I'm going to pick up my pencil and start again on the other side, so I'm going to unite that and start again at negative 3, and it's going to go all the way up to 7. And it does touch that because we did have that with the equals part there, touching that. It's going to be 7, so that's going to be a bracket. So there's our domain for that function. So what I want you to do is I want you to pause the video and to work on these two problems by yourself. And then when you come back, I'll have the answers for you to double check. All right. So let me just pause this. All right, and hopefully you came up with these answers right here. Again, noticing in the bottom, that those parts can't be equal to 0 on the top. We don't have to worry about it. I can put any number in for x up there on the top. So again, solving those pieces to identify those places where it can't be, and then writing out the union of all 3 of those parts. Same thing over here. In this first part here, I would have factored out the x first, so I can see the parts to this beforehand. Now, don't cancel out this x with that x. We want to still deal with the original equation. But again, this x times x minus 12 on the bottom, again, can't be 0. So that's kind of what we came up with there. So, all right. Let's move on to domain and range for this next part. So this time we're given a little graph, and want to talk a little bit about the domain. So again, we're reading left to right. So if I look at how far left it goes, so what, 1, 2, 3, 4, 5, 6. So it looks like it goes as far as negative 7 on the left side. All right. And it's got a closed dot there, so that means we can include that. And as I read to the right, it'll go all the way over here to 1, 2, 3, 4, 5, but it's got an open circle. So we put a little parentheses. Range, again, so domain are like my x values. Okay? My range are like my y values. So again, I remember that x comes before y, d comes before r. So I'm going to start here, always go low to high. Domain is always left to right, and range is always from low to high. So as I'm reading this, it looks like the lowest this goes is right here, and that looks like that's down at negative 3. So I'm going to start at negative 3, and again, that's a closed circle, so I'm going to put a bracket. And then it's going to go all the way up here to the highest point there is here at 1. And again, it's got an open circle there. So I will put a parentheses there. Okay. So practicing a little bit with range, we just had these two equations. We just did those back up here with the graphs. So I'm going to kind of have you just kind of remember those graphs. So again, this graph here was the graph that looked like this. If you remember right, it started here at negative 2 and then kind of went like that. So we talked about the domain on this one already, but let's look at the range. So again, range is low to high. The lowest it goes here, I'm looking at the y-axis, is 0. And because it's got a solid dot on there, it does touch it. But if I look here, this is going, yes, it's going to the right, but it's also going up and to the right. So it's kind of slowly rising as we keep going up. So that would go out to infinity. And again, infinity always has parentheses. And if you remember this graph from up above in the domain area, that graph was that hyperbola. Remember, it had that asymptote right here at 5. and then it had another asymptote, the horizontal one here at y equals 0. This was at x equals 5. So that graph was sort of like this. Sort of like this. Except now with range, again, we're dealing with reading from low to high. So we're looking at how low does this graph go. It goes all the way down to negative infinity. So again, infinities never have brackets. They always have the parentheses. So as I travel from low to high, I'm kind of going up. It looks like it's going to kind of hit this little wall at 0. And again, doesn't touch it, just kind of approaches that. I'm going to pick up my pencil, so unite that from picking up another side. So it kind of picks up at the 0 and then goes all the way up to infinity on that other branch. So kind of in parentheses. So doing some other examples, we can kind of look at the range, and again, this one here, if we graph it, it's already over here, so you can kind of see what that graph looks like. And again, we'll talk more about parent functions and the 12 basic functions, so you can kind of recognize that that is a hyperbola already, and we'll talk more about that. But if you need to, you graph it, and look what that graph looks like. So when I look at this graph, and the lowest it goes is negative infinity as I keep going up. It's going up here, it's going to level off at 0. So it's going from negative infinity, go up to 0 but doesn't touch it. Pick up my pencil, start up on the other side, starts low at 0 and goes all the way up to infinity. That one. Get a little second practice, and again, you can go to Desmos and graph that. And you certainly could go back to that and clear everything here. Oops. And type in square root of x. You can see it's got that same thing as that previous one, but back here centered at 0, 0. So if you look at what that graph looks like, and we're here, it goes up like that. So again, if I'm looking at my range, again, looking at how low does this graph go, and the lowest it goes there is 0. Doesn't go any lower than that point right here. So, oops, and it does touch it. So I just about made a mistake there. And that's fine as long as we correct our own mistakes. And it does start at 0. That's the lowest it goes. And this is going, yes, it's going to the right, but we don't worry about that. It's going, how far up does it go? And it looks like it's going to go up to infinity. Again, infinity's got parentheses. So, we just obviously just did this one. So let's move on. And what I want you to do is either through reasoning, or if you have to for now, we'll have you graph each of these and come up with a range. So what I suggest you do is pause the video and give it a little try, and then unpause it and come back and check your answers. All right, and you're back, and hopefully you came up with these answers. If you didn't, make sure to ask them in class, and we can certainly discuss them a little bit more. But briefly, again, this one here, again, remember, we got square root. So again, the numbers underneath there can't be for range. Looking at what the outputs will be. So again, anytime we square root something, our outputs are always going to be positive. It kind of runs through here a little bit. But yeah, make sure to ask some questions. But right now, after going through all this, you can now go into lesson 1.1, and you should be able to do worksheets B and worksheet C. So I believe the worksheet C, the required is only half of those. So there's additional practice to do the other half. Wish you luck, and you should do well.